Okay, we're answering questions on the review, and Jacob's question was on, I think this is the right worksheet. Which number?
8.
And question number?
13.
Okay. So it says to use years since 1990. So for your X list, or list 1, you're going to put 0, 2, 4, 6. That was your main question? Okay. Then you want to look at the scatter plot, decide. Did anybody have trouble with the last part of this? When does it exceed 35%? I don't know if anybody got this far. I've had several questions on that. Look at these percentages, guys. Did they move the decimal over on these? No. So when you use 35%, what are you going to put in for y?
35.
Just put in y equals 35 and then solve for x. Okay? That's all you're doing on that second part. After you do the first part in your calculator, then put a y equals 35, and you're going to have to write it down and solve. It's not going to do it on your calculator. Does somebody else have a question on anything on worksheets 8, 9, or 10?
What's the answer?
On problem number 8 on here? Diameter of 10 inches, so that would be put in an x of 10. So we'd have y equals 6.301 x of 10. I don't know what happened to my cursor here. Plus b, which is negative 1.044. So then it's just a typing. Is it 62 point something? Or? Yeah, I was trying to do it in my head. 61.966 is exactly what I got. Yep. So it said use this to predict the age of a tree. So I would say about 62 years old. Make sense? Yeah, that was nice. They gave us everything we needed, right? A different question on any of those worksheets, guys? Claire, right? You go by Claire? Okay.
I know that when we very first started this class, he gave us a different way to do the distance formula.
Yes.
And
Okay. Yeah, I think
it's 9B.
okay, thanks. I was looking for where there was some of those.
There's just on top of it. This is her first idea.
Okay, 9. Worksheet 9. Yes. Okay.
I'm not. Kids are asking us. I'm dying.
Okay. Worksheet 9 has an awful directions here on part. This is 9B, number 9. Is that right? Okay. It says find the distance formula, find the midpoint, find the slope, and then find the full equation. Okay. So distance, what my suggestion was, think of it as change in x squared plus change in y squared, and then square root it. So it's like Pythagorean theorem. So if I were doing this question from 4 to 1, the x's are a distance of 3 apart. From negative 2 to positive 4 are a distance of 6 apart. Everybody okay with that? You can subtract them. So we get 9 plus 36 is 45. I don't know if I would give full credit for that. I would give full credit for 3 square roots of 5 or even the decimal. And just a little, probably on this one, I would let you get away with square root of 45, but you really should simplify if you're going to leave it in radical form. If I go 2 decimals, 6.71. Did I do that right? Or did I do something wrong?
I just have a question.
Yes.
Is that typically how many decimal places you want us to those?
Sure. Yeah, if it doesn't specify, I pretty much have to take whatever. When you do a line of regression, it can make a really big difference whether you go out a whole bunch or just round to like a tenth or something. But as long as I can tell what you did, I'm probably much going to let it be right unless I can't figure out how you got something. Midpoint, remember guys, I just do the average of the x's and average of the y's. Remember? So if I add the x's, I get a 5. If I add the y's, I get a 2. I got to divide them both by 2, so I get 2.5 or 5 halves, comma 1. I don't care if you leave it as an improper fraction or a decimal. Slope. If you do all your slopes backwards, it's going to be a rough summative, okay? You got to remember slope is y over x, right? So something like this. I got -2. Does anybody else get that? Yep, on number 9. Okay. And then for part D, it says the equation of the line. So if I pick 1, 4, and my new slope that I already found was -2, it's not new, it's the slope. So then I would do like y minus 4 equals -2, x minus 1, and I could distribute and solve for y. Did I cover all those ideas one more time? Let's see. This would be +2. Is it +6? Did anybody get that? I'm just skipping steps because I'm out of room on my slide. Anything else I can help with on worksheet 8, 9, or 10?
How long is the summative round? How many questions?
I think it has 17 questions. It's 2 sheets of paper, front and back. There's quite a bit of room between the questions. It's 50 points. So it's probably more of a quiz than a test, but, you know, I'm not real picky. Sometimes the summative will be 70, sometimes it'll be 80. It just depends how many questions. I do try to take into consideration how long we've spent on the unit. You know, if we've spent 3 weeks on it, it's going to be worth a lot of points. But this one, basically, we've spent a week reviewing linear equations, so it's worth 50 points. Anybody else have a question about? Yep, Jacob.
5, 9, 8.
Is this 9 that I'm on right now? Okay, so I'm just going back to number 5. All right. Anybody have an idea how to start this one? It's in standard form, but is that what most of you would do to find, we need to find the perpendicular slope to this, so most of us would probably rearrange it. I would have. And then I have to divide everything by -4. This turns out to be a really disgusting y equals 5x plus 5/4. Is that what anybody else got?
Yeah.
It really doesn't matter though, because we don't care at that point, right? All we want is the slope.
This is 5 already?
Yes. But now we need the perpendicular slope. So -1/5. Did you do that part? Okay. And then we don't care about anything else except it has to go through this line. Now I'm going to pretend it wasn't pretty because it really is pretty, but I would have used this guy. So I would have said y minus -1 equals -1/5 x minus 0. But this is actually the y-intercept, because over 0 and down. So it's actually just y equals -1/5 x minus 1, which is what you should get when you fiddle around with this guy down here. Okay? Good job. Do we need to go through another calculator example, or do you remember how to do all that stuff? It's on worksheet 8 if you wanted me to go through one. We're good? On worksheet 8, there is one on the quiz like, like number 2 or 3. What's the trick on 2 or 3? Both. It's really mean. But when you read this, this is supposed to be y equals mx plus b. So what's the y?
No, B. That's
Y represents the number of books. So you want to put that in list 2
That's mean.
and this in list 1.
Why do they do that? Okay. I'm glad. Because I didn't get the first one.
If you don't, and you put them, it's not that bad if you have the newer calculator, because when you go to do the stat
You can
regression, you
switch
just
it
type
to
L2 and
Yeah.
L1.
Which is what I did, but I did it wrong.
Yeah.
And then I was like, fix it.
Claire, did you have a question?
No.
Anybody else? Something I can help with? Right, I'm going to pause this for a second. All right, this worksheet is the kind of vanilla ice cream colored worksheet. I think on the paper box it's called Ivory. And we went over this in class, but I forgot to record, so I'm going to record this right now. It says review of exponents. This worksheet is due on the next homework check, which is next Monday. I have the 29th, okay? Due tomorrow then is the homework check that has 8, 9, and 10. Worksheets 8, 9, and 10. All right, quick review. I tell algebra students, when in doubt, write it out. So if you can't remember what to do with this, if you write out x squared means this, x cubed means this, then you will remember that you end up with 5. So you are adding exponents when you multiply the bases. If you had a y to the 4th over a y squared, that's not a good example. How about a y to the 8th over a y squared? If you were to write it all out, which is why I didn't want to go with that many, I think that's 8. You would, we like to say cancel, it's really divide out. You would divide out 2 y's and you'd be left with a y to the 6th. All right, a negative exponent, I like to say cross the line, change the sign. So if you have a negative exponent, I'm going to do these down here at the bottom. Right, if you have like a 2 over a negative x to the negative 3, then it needs to go up here, so you'll end up with a 2x to the 3rd. If you had 4x to the negative 5th over y, these need to move to the bottom, but it is good to remember the 4 doesn't have an exponent. If it did, it would be a 1. So you're going to move the 5x's to the bottom with the y. And the third case is the third case is if you have an exponent on the outside, like a negative 2 out here, it flips everything over and then squares it. So you would end up with an x squared over a 3 squared, which is 9. Be careful you're not multiplying 3 times 2, you're squaring it. Then we skipped this one. We need to go back and talk about the power rule. If you had an x to the third, like to the 4th power, you'd write out x to the third, x to the third, x to the third, x to the third. If you wrote those all out, you'd have 12 x's, so you are multiplying those. It's not 3 to the 4th power, it's 3 times 4. All right, and expanded exponent rule just reminds you that when you have something like this, it's 2 to the 3rd, x to the 6th, and y to the 12th, and then you need to calculate what 2 to the 3rd is. That 3 exponent out there applies to everything inside here. And you get the special rule that anything to the 0 power is 1. So then in class we did a couple examples. One they asked to see was number 4, I think. And the trick with me explaining this number 4 is that everybody kind of does it in a different order. If I just simplify on the top, there's a plain old 2 here and a plain old 2 back here, so I can multiply those together and I get 4. I have an m to the negative 2 that I'm just going to leave alone. If I added these together, I'd get an n to the negative 1. Okay, because they're multiplied, I'm going to add the exponents. Down on the bottom, this 2 applies to both of these, so I end up with an m to the 4th and an n to the 8th. All right, again, the negative exponent needs to cross the line and move down here, but the 4 does not. The 4 is a coefficient. It has its own exponent power of 1, if you want to think of it that way. Now, there was 4 m's and an n to the 8th down there, and we're moving an m squared and an n to the 1, because when these move to the bottom, okay, cross the line, change the sign. So we end up with a total of 6 m's and 9 n's down there. I definitely could have done that one in a different order, so try it yourself a different way if you want, and it should come out the same answer. The only other one that they did together was maybe number 7. We decided to get rid of this negative 3 out here by flipping the whole fraction over. So we ended up with x to the negative 2, y to the 4th, 2x to the 0, all over 2y squared, and we still had a power of 3 out there. We just flipped it to make it positive. Then I suggested we clean up the inside. An x to the 0 is just a 1. A 2 divided by a 2 is just a 1. So we have a 1 times 1, which is just 1. These guys belong on the bottom. Alright, so we kind of have a y to the 4th times 1 times 1. And a y squared x squared. That does simplify even further, right? Because these two y's will knock out 2 of these. So we end up with a y squared over an x squared. And then the whole thing is to the 3rd. So we get a y to the 6th over an x to the 6th. Again, you can try it in a different order. See if it comes out the same at the end, okay? I'm sorry I forgot to record that part during class, so I hope that helped a little bit. Good luck. And again, this one isn't due till next week.